This Math Talk's another video on optimization problems with quadratics. And it begins with the problem: a farmer has 1,200 meters of fence to construct 3 identical adjoining fields along a straight river. If the river serves as a natural barrier, and from that means that you don't require fencing on that side, what dimensions will maximize the total area of the fields? And so, like the last question, we begin with a let statement. And so we let A represent the total area of the 3 fields. That's what we're trying to optimize. Let W represent the length of each side perpendicular to the river, and L represent the length of the side parallel. Probably easier if we get a visual on this. Our diagram looks something like this, where we have the blue river, we have 3 adjoining rectangular fields, an overall width of W, and overall length of L. What I'm trying to do is optimize my area. So I have area equals L times W. Now this is a little different from the revenue and profit questions that I worked on in the previous video. In those questions, we had revenue and profit depending on a single variable, X. In this situation, we have 2 variables on the right-hand side. We're trying to optimize our area, but we have 2 variables on the right-hand side. So the first thing that we need to do in this problem is eliminate one of those variables. So when I look at the relationship L plus 4W, in other words, the total perimeter of fencing, I recognize that that has to be the 1,200 meters of fence that I have to construct my fields. So I can rearrange that relationship to say L equals 1,200 subtract 4W. That would be true at all times. So inserting that into my equation, I get area equals 1,200 subtract 4W times W. So I've just replaced my L. Once again, we're in the same situation that we were before. We're trying to find W-intercepts on our graph. And once again, we're already in factored form. This is really easy at this point. 1,200 subtract 4W equals 0. That leads to W equaling 300. As well, W is equal to 0. Graphically, we get something that looks like this, an A versus W graph, and our x-intercepts would be 0, 0, and 300 and 0. Just as we did in the last video, we recognize that to find the vertex, we need to find that axis of symmetry, or the W value that lies halfway between the 2 W-intercepts. We've done this several times. We simply take the 2 W-intercepts and take the average of them. In other words, 300 plus 0 over 2, and we get 150. That would allow us to determine the length value at that vertex, and that would be 1,200 subtract 4 times 150, or 600, leading to an area which would be 1,200 plus 4 times 150 times 150, or 90,000. And so the farmer, quite simply, just needs to construct his fields with 4 sides of 150 meters in length each, perpendicular to the river, and one side 600 meters in length parallel, to maximize the total area at 90,000 meters squared. That's all there is to the problem. Thanks for watching.